Hello developers, let's start developing. Today we're taking on the 10th task of the 2024 Advent of Code. Yesterday was the first day when I didn't finish the task, so I only have 1 star on the 9th task. We'll get there eventually. So part 2 of that is still pending, but nevertheless we're gonna take on the 10 tasks, which for now seems like a bit easier thing. What's the story? We have a map of a park or something like that, and we need to find a hiking trail. A hiking trail is very nicely defined. This could have been a very hard task, but it's very nicely defined. That is an even gradual uphill slope. So it means that if the first point is at elevation 0, the next one should be at elevation 1, elevation 2, and so on and so forth. So we can see, and now we need to find how many 9s are reachable from the 1. And note that the question, a trail is a path that starts at 0, ends at 9, always increases by a height of exactly 1. And the thing is, the score of the trailhead of the 0 is the number of 9 height positions. So it's the number of 9 height positions. So we don't count the ways in which we reach the 9. It's just that we can reach the 9. So in this scenario, for example, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we reach the 9. Or we can go 1, 2, 3, 4, 5, 6, 7, 8, 9 to reach the 9. And those are two distinct trails, I would say, but they can just count one because we only have the one. And in this case, we actually have 4 different trails when we can go through that. Basically, we have 2 ways to get out of the 0 and 2 ways to get out of the 5. Multiply them together, we get 4. But for the first part at the very least, we're just starting from trailhead and we're counting up to a different 9. So, how do we do this? Well, as always, the first thing there is, we need to pass the input. And the input is actually something like this. So it's a matrix of numbers. Note that this is not really a matrix, this is more like a graph where we have a node with a value and we need to find its neighbors. And it's defined that its neighbors are horizontal and vertical, so the items on the diagonals are not neighboring. Anyway, we're gonna need to read the lines, and let's just change the type of the input. It's gonna be a number array of arrays. So that's aka a matrix. So we're gonna say lines.map. We're not splitting on a comma, we're splitting on nothing, and then we're parsing those splitted to that. And we're returning that, and that is a matrix of numbers. So I will rename this input to elevations. As always, I will just do a print matrix of this, of elevations, and yeah, let's just try it with no parameters. I think that's what we kinda want. Let's just see if this is what we started with. Yep. So we are reading it correctly. Now, we need to actually find all the trailheads. and I definitely feel that we're gonna need this. So let's start with that. So I will define a set, why not, or an array. Now it can be an array. And yeah, we're gonna use a nested for loop for this. Yeah, we have the y, we have the x, and usually we can call this our index, but y and x are kind of okay. So everything is okay except for this. So we're going through all of them and just looking to find the zeros. When we find the zeros, those are our trailheads. And now we're gonna need to do something like this. For of x, y of trailheads. So we're taking the x and the y directly. Those are the x and the y coordinates of the trailhead. And note that the coordinate system is a bit off, since the first coordinate goes that way and the second goes that way. That is the first one is the y and the second one is the x. People get confused by that a lot. So we have our x and the y, and now I will say count. I will say let total score be 0, and let's just do count. What is the term for a 9, for example? Count score or something like that. Yeah, count trailhead score. Actually, I will take this up as a trailhead because I will want to call it like this, and the total score will add that to this. Great, this is solved with the simple detail that this is not actually implemented. And if we just say return 1, we will have a very nice check whether we count all those zeros actually. So now it will return an incorrect result, which is the number of all the zeros, which is supposed to be 9 trailheads. So they have some scores, we need to just add them. Now for each trailhead I will independently determine, because they're kinda independent. And how do we do that? So I'm guessing that we would have to use some variant of flood fill. And yeah, this was kind of like that. The thing it generated, it had a queue and it had the different directions. So let's define a queue. That queue will have our trailhead, and we can just say while queue.length is bigger than 0, do something. Something like this. Don't worry, we'll take care of it. So, first of all, this is an issue that irks me in TypeScript, but it cannot be solved. But this specific scenario, when we check that the queue has a length that's bigger than 0, which means that we can take the first item from the queue. So we know that this is a point. But in general, when you shift take the first item of the queue, that queue could be empty, so it could be undefined as well. I will just say, I know that it's an undefined. Then, yeah, we need the current elevation, and of course we need its 4 neighbors. I think that was wrong. Actually, I will just define the neighbors. So these are the points that are the neighbors. Out of these, some will be valid, which means we can continue using them. Some won't be valid. For example, if we have a point with elevation 1 and we have two neighbors with elevation 2, those are good. But the neighbor with elevation 7, we don't need that. So the good neighbors are from the neighbors, filter those. Oh yeah, I would have forgotten that. Filter those, so here we have two filters and I will actually put this up here. That's a good catch. I would have had a bug and I would have gone back. So we're generating all the possible neighbors, even the ones that don't exist. And note that this guy doesn't have 4 neighbors, it has 2, because 2 are out of bounds. So this says, well, we're gonna do it this way. Generate all 4 and then filter out those that are out of bounds. Of course, I would like better to have a width property and a height property and use that instead. This is much more readable. On the other hand, I would like to extract this to a method. Point in bounds, yeah. And it's gonna be the exact same thing. And we're just gonna say filter by point in bounds with that width and height. So it's bigger than 0, less than width, bigger than or equals 0, yeah. Looks okay. So out of those neighbors, we're gonna get the good neighbors, which is another filter on a filter. Well, the elevation of x and y is equal to the current elevation plus exactly 1. Note that Copilot makes good guesses. It's not always the correct one. Yeah, it's over there. So it was initially like this. That's similar to what we found, but not actually. And what we're gonna do, push the good neighbors to the queue, and that's all that we want to do. So this will loop through all of the neighbors, constantly moving upwards and upwards until it gets to a 9, which has no good neighbors. On the other hand, how do we take care of the 9s? Well, we need a counter. Let destinations. That's a new set of string. Yeah, why do I use strings and not points? Because points have a weirder equality. So we're gonna have yet another point to string method, which will return this thing. So no destinations return. Why this is set? Because if we reach the same 9 twice, we don't care. So this is kind of suboptimal because we will kind of go through all of the paths, but it's doable. I don't think we need to optimize it yet. We might need to do that later, but let's say. So now I will just add that if the current elevation is exactly 9, which is the target, then we just add that to the destinations and continue onward to the next. Because we don't really care. We got to the 9. We know that it's not going to have neighbors that climb up. So this would be just idle work. And then we can just return destinations, the size of destinations. how many destinations are actually reachable. Let's see if this works. It says the result for part 1 is 36. So let's move on to the big input. If this is indeed 36, and it is, and the big input is a bit bigger with a lot more zeros, I think it's something like 317. Basically, I checked it by saying find me all the zeros, if that matters. So let's start it and see if this actually finishes in a reasonable amount of time. It says 13 milliseconds. It actually took longer to load the file. Now that part should go down. Yeah, so 53 milliseconds or something like that, but we still get 760. And let's see if that is the correct answer. Yes, we got our 18th gold star. Let's see what the second part is. And even before I read it, this can be relatively tricky because there are lots and lots of tricky stuff that we can do with networks. So I might need to take a part 2 about this. But let's read it and let's see what happens. Returning with yet another slightly charged wave. Aha, it's not the score, the rating. As I mentioned, the number of distinct hiking trails with begin at the trailhead. So this is a single trailhead and this is a single 9 that we can achieve, but we can go with 6, 7, 8, 9. We can do it this way or we can do it this way, and those are 3 different trails. So the destination is the same, the origin is the same, only the path is different. Single trailhead with a rating 13, rating 227. Yeah, this is a tiny thing and it has 227. Yeah, this is totally constructed example, but still. I have a feeling that we might do a quick hack in the sense that we're not gonna just register the destination but the whole path, and if that is different then we're okay, which means that this approach will just need to be slightly modified, but I've been burned before, so we're gonna try that in a separate video. So don't forget to click like, subscribe, not the bad button, don't click the bad button, and keep developing.